9 o'clock, coming around. Ladder 10:30, coming around. 10:30 upper lower.
What was that? What the hell was that? It went by like we were standing still. Blue leader to group. Get off the air. Going by at 2 o'clock. What the hell is it?
1944 Germany. The war has turned against the once unstoppable war machine that was Germany. Any hopes of victory faded throughout 1943. Even the most die-hard of supporters for the war knew something was wrong. Constant reports of strategic fallbacks were not unnoticed by the citizens of Germany. With the war coming to the borders of Germany itself, the leadership turned to anything that would turn the tide. Desperate new solutions were sought to change the tide of the war. The propaganda ministry picked up on this and used these new and mysterious weapons as a tool for fortifying the spirit of the German people. The V1, V2 and Me-262's production were in full swing. Of less excitement were the V2 and V3 bases in northern France that were already overrun and in enemy hands. Enemy bombing had rendered them useless before they could even operate. Even if the Allies hadn't landed in France, the facilities would never have been able to operate as the Allies were fully aware of them. Theoretically, if these bases were up and running, they wouldn't have changed the outcome of the war, but they would have increased the death toll on civilians. That puts the V in vengeance weapon. Revenge for the bombing of Germany. One of the main issues Germany had was not having control over its own skies. Famously, the Air Minister once said, "No enemy bomber can reach the Ruhr. If one reaches the Ruhr, my name is not Goering, you can call me Mayor." That was in August 1939. The German Air Force was a mere shell of itself in 1944. The quality of its pilots, training, and amount of operational planes had taken a steep downturn. An edge was needed over the Allied planes. A lot of resources were gambled into the jet fighter program, which led to the world's first operational jet fighter plane, the Me-262. Rushed production, little testing, led to a disastrous program. Engine reliability was a joke. To speed up the development and to get into mass production, the design was frozen with all of its faults, just so that mass production could happen. That's how engine lifetime ended up at around 10 hours, to maybe at best 25 hours per engine. A shortage of rare metals did contribute to this, but wasn't the sole contributor. Many completed 262s didn't even reach their fighter squadron as they were destroyed in transit. Even if the planes did get to their squadron, fuel shortages meant that large amounts of fighters couldn't take to the skies. With the even worse turn of the war in late 1944, the emergency fighter program was brought in. This is where we see a whole host of new and radical aircraft designs. These planes were all focused around small single-engine fighter planes. The requirements for a plane in this program were that they cost as little as possible and were simple to make. The only fighter in the program to reach production and to actually see combat being the HE-162, the Volksjäger. The Volksjäger was a plane with a mostly wooden construction. It was powered by one jet engine. The plane was manufactured in underground slave labour factories. With around 300 built, they were responsible for only shooting down one Allied plane. The SS took it upon themselves to develop a program separately from the Air Force to deal with the heavy bombers. That's where the BA-349 Natter comes in. Natter means snake. The founder of Bachem Werk, Erich Bachem, had the idea for a rocket-powered interceptor as early as 1939. At the time, there was no need for interceptors. The idea was laughed out of the German Air Ministry. Not once, but twice. Propeller fighters were proven and reliable. The Air Ministry did not need a rocket-powered plane. Plus, the technology was not quite there. For now, it will be put on the back burner. Unknown to Bachem was the secret development of the Me-163, another rocket-powered fighter. The Air Ministry didn't need another lesser project to divert their attention. In 1944, Erich Bachem took his project to the SS, where it was approved by Heinrich Himmler. Himmler had just been humiliated in his short role as a general and was looking for anything that could restore his credibility. The BA-349 has some advantages that made it viable for late war Germany. The 349 has a wooden airframe. While resources were low, that wasn't the sole reason for the material choice. The all-wooden construction for the fuselage allows greater allocation of work. With the move to total war, wood workshops were being utilised in the war effort. An example of this would be the Bf-109's G, rudder and tail fin. These parts didn't need to be metal. The job of making these was sourced out to wood workshops, thus freeing up metal manufacturers to use their time making other components. It also helps that materials weren't as plentiful. The Natter was far down the list for resources. A partner in Backham estimated that an airframe, minus the rocket engine, would take around 600 hours to make. Weapons, pilot gauges, rocket boosters and other necessary equipment took 400 hours to make, bringing up the rough total time of production cost to 1000 man-hours per Natter. Another advantage was vertical takeoff. Don't overlook such a simple thing. Planes always need a clear area to take off and land from. All the support equipment needed to run planes is naturally located nearby. Quarters for the pilots, planes, fuel storage, all these vulnerable eggs in one convenient place. With a large strip for an airfield, they're fairly easy to spot in reconnaissance photos. If the enemy knows where an airfield is, steps will be taken to counter it. When air supremacy is lost, operating from fixed airfields is very dangerous. Vertical takeoff is a way around this. Side note, steps were taken to hide German Air Force operations. The Luftwaffe in 1944 utilised German motorways and grass strips to take off and land from. The Natter used the same rocket engine as the Me-163. While the rocket engine was powerful, it was unable to launch a plane vertically into the air. To fix this issue, 4 solid fuel rocket boosters were added near the rear of the plane. On takeoff, these boosters will provide thrust for 12 seconds before being removed with explosive bolts. The small airframe provided 2 major bonuses. The small airframe would make the Natter hard to target by an enemy's defensive gunners. The profile of the plane is only 6 meters long with a wingspan of just under 4 meters. This is very small, especially when compared to heavy fighters. Heavy fighters were the preferred interceptor for heavy bombers. The small profile made transportation fairly easy. Just like the V1, the wings were easily removed. There are no moving parts in the wings. The ailerons, which are normally located in the wings, are located in the tail section. A fuselage could easily be loaded onto a normal truck or a simple trailer. When at the launch site, the wings could then be refitted onto the plane with no issue with control cables. It was originally considered that the Natter would be launched from a bunker complex. This was put forward in the second application to the German Air Ministry in 1941. This was rejected. The bunker complex resembles a U-boat construction facility and also a V2 launch site, Valentine submarine pens and the blockhouse. This plan didn't go ahead. 1. Because these facilities are expensive and take time to produce. 2. They were really obvious targets for heavy bombers. Both Dimension's subbase and V1 site were bombed until inoperable. The design was shifted to a mobile truck platform. For launch, a Natter could be placed vertically between 2 trucks or a truck and a trailer. From there it was redesigned once again. The Natter would be attached to a platform built into a stripped down pine tree. There was also a more permanent launch solution in the form of a metal structure with concrete foundations, 3 of which were built. You can still see them today in satellite pictures. They're due for demolition soon, so have a look while you still can. So, why rocket powered? There are advantages to rocket powered planes over prop and jet planes. Prop planes take ages to gain altitude. It also requires a long time to climb from ground level to high altitudes. Where air is thinner, prop planes perform worse. Jet planes can travel at speeds that props could only dream of. They also perform better than propeller planes at high altitudes. Like prop planes, they still take a significant amount of time to climb to high altitudes. Jet planes at the time of late World War II were vulnerable on takeoff and landing. There were easy pickings for enemy planes as they struggled to accelerate quickly. Rocket planes can climb very quickly, so they can get to the height they're needed at very fast, and there was low risk of interception en route to the target. Range is their biggest weakness. The Me-163 was designed with the purpose of hunting heavy bombers. Stationed near industrial areas and other likely targets for bombing, the 163 could get to 30,000 feet in just 1 to 2 minutes. Very impressive for the time. The odd choice for the armament of the Natter. The Natter's armament was 24 73mm rockets, mounted in a hexagonal shaped rocket rack in the nose. The R4M rockets were the only ornament. One rocket hitting a heavy bomber would cause enough damage to bring it down. Each rocket weighed close to 4 kilograms. In flight, fins would spring out to stabilize the rocket's flight path. The effective range was said to be 1,000 meters, which is just outside a bomber's defensive gun's range. Natter pilots were intended to fire within 100 meters as to avoid missing. Originally, the R4Ms were developed for only use by heavy fighters. They were released for use with the Bf-109, the FW-190 and the Me-262. They ended up seeing more use on fighters than they did heavy fighters. There was an experimental rocket rack for 32 55mm rockets. Smaller boom, but more volume of fire. This variant was never test flown. The choice for rockets as a primary armament over more traditional autocannons is rather interesting. The plane's semi-disposable nature and the strength of American bombers was the main choice for unguided rockets. The German 30mm cannon was rather reliable at taking down bombers. A few hits could take out a bomber compared to smaller calibers such as 20mm. A heavy bomber could shrug off multiple 20mm cannon rounds. The machine cannoner 108 wasn't perfect and it did have its downsides. The Mk108's rounds, while packing a big boom per round, had a rather low muzzle velocity. The rounds dropped almost 50 meters for each 1 kilometer traveled horizontally. That's around the height of Nelson's column. The low rate of fire of the guns also didn't help. A fighter plane could have the bad luck to have a bomber pass through its sights, with 30mm guns blazing, but due to how fast the fighter is flying and how slow the rounds are, a bomber could pass unscathed through its crosshairs. The theory with the rocket rack was that so many rockets are flying in a short period of time, at very close range, that even a low-skilled pilot couldn't miss their intended target. Remember, only one rocket needed to hit its target. How an average mission should go. The pilot and the Natter would be on standby near an industrial or built-up area. The 4 minutes of flight time limited the Natter's range, so launch sites had to be close to priority targets. When a daytime enemy bomber formation was located, the pilots would scramble to the Natter that they were assigned to. Inside the cockpit, they would ready themselves with their gear. The autopilot system would then be programmed externally, not by the pilot. The autopilot was for the initial launch. The flight computer controlled fins around the rocket nozzle to keep the Natter's flight path steady for the first section of the flight. The computer only controlled these special fins, not the plane's control surfaces. When given the order, the pilot would start the launch. 4 booster rockets would ignite along with the rocket's engine. After around 12 seconds, the bolts holding the booster rockets would detonate, removing the now useless weight. The pilot would take over the controls once the autopilot had turned off after reaching its programmed height. With no radio contact, there was no radio in the plane, the pilot would head in the direction of the bomber formation. To reach this height, it took around 60 to 120 seconds from ground level. The pilot now had just over 2 minutes of fuel left for their mission. The pilot now picks a bomber out of the formation as their target. Closing the gap, he jettisons the nose cone, covering the rocket rack. Close to 100 meters, the pilot presses the firing button for the rockets. The rockets fire electronically with a short gap between each rocket fired. Hopefully, the pilot doesn't get hit by the defensive guns of his target in this almost suicidal attack run. There was bulletproof glass and a metal plate in the front of the plane. Theoretically, it should be able to stop a 50 cal round, the main defensive weapon of Allied daytime bombers. Out of rockets and almost fuel, the pilot dives the plane down to a height of around 3,000 feet. The job is done. One thing I passed over earlier was when I mentioned the semi-disposable nature of the aircraft. In my video, this entire time, I have not mentioned landing gear or how the plane is recovered. The BA-349 was a semi-disposable plane. The pilot, when ready, would disconnect the steering column and push it out of his way. Then, they would open the cockpit canopy. Next, they would activate the parachute that was in the rear section of the plane. This action also blew explosive bolts in the middle of the plane, separating the front from the back. The pilot would then be thrown clear of the cockpit when the plane separated. The rear section of the plane, containing a rocket engine, would float down to Earth. The pilot would also descend to Earth on their own parachute. The front section would fall uncontrollably and be smashed to bits most likely. The plane was intended to be semi-disposable. The most expensive part of the plane was the rocket engine. That's why it needed to be recovered after a mission. That way it could be fitted into a new BA-349. Multiple test flights of the Natter were done, several manned and unmanned. Flights were done at first by testing flight characteristics unpowered. This was done by towing the Natter behind another plane. The test pilot would then test the flight characteristics before bailing out. There were several BA-349s with fixed landing gear. These were made early on in development. The landing gear was to do tests on the aerodynamics of the plane without having to waste time and material recovering and rebuilding each Natter tested. Later, there were more tests with a separation and pilot bailout procedure. Tests showed that the Natter had very bad flight characteristics at slow speeds. Because of this, the pilots had to bail out ideally with the engine still running. The next phase of tests were rocket-powered launches. First unmanned, then radio controlled. Finally, we have the first and only manned rocket-powered launch with a pilot. On the 1st of March, the pilot, Natter was the first pilot to take off in a vertically launched rocket-powered aircraft. Within a minute, he was dead. The cause of the crash is not entirely known. The investigation into the death thinks it was mechanical error rather than pilot error. Backham did not want the test flight to happen from the start. He was pressed into organising the test flight by the SS, who wanted to speed up the program's development. Even after the incident, more test flights were organised and were due to happen on Hitler's birthday. The launch sites, which were supposed to be used, were captured by the Americans. The test pilots and the BA-349s were retreated deep into Germany and towards the Alps. It was thought at the time that the Alps would be Germany's last stand rather than the fight for Berlin. Around 40 Natters were fully completed. It is said that there may have been close to 70 if including partially completed airframes. What I still don't understand after all of this is where was the fuel coming from to run the Natter project? The BA-349 uses the same rocket engine as the Me-163. The Me-163 was arguably the more proven and reliable program. The first 163 fighter wing was operating by mid-1944. These planes used cannons, they had great flight characteristics, and even had reusable aircraft. The reason that the Me-163 only saw limited use was because of fuel shortages. The rocket engine that the 163 used two fuels, C-Stoff and T-Stoff. With the Allies targeting production facilities that produced these chemicals, there were massive fuel shortages for rocket fuel. What was produced was used in the V1 project instead. Maybe JG-400, the Me-163 squadron, was a lesser priority for fuel than the SS unit requesting fuel. The SS were normally at the top of the list if they asked for any resources. I'm not saying that the Me-163 program was fully reliable. We can sit here and talk for ages about all the flaws it had. What I am trying to say is why gamble everything on something new when there was already a working program? What happened to Erich Backham? He escaped the eye of the Russians and the Americans, who were sweeping up scientists. He moved to Argentina. And this bit puts a smile on my face. He set up a factory building guitars with interchangeable bottoms. He just couldn't escape the idea that things can be split in two. Later in his life, he moved back to Germany. Before we finish, here's one interesting fact. Any Natter you see with insignia, such as a swastika or the Luftwaffe insignia, is wrong. The Air Ministry didn't allow insignia on disposable aircraft. I hope you enjoyed this video. Thank you for watching. If you like this, there are many more videos like this on my YouTube channel, so if you have the time, please check them out.